Welcome to the convention, and welcome to Colorado. Colorado is a unique and beautiful place with a rich geologic history to match. From the cliffs that provided shelter to the early native peoples, to the minerals that first brought European settlers to the area, to the mountain vistas that draw tourists from around the world, Colorado's geology has played an integral role in the area's human history as well. To understand how this place came to be, let's take a brief look at Colorado through geologic time. Like many of the audience joining us from abroad, Colorado has taken a long journey to its current location. Let's go back in time to the start of this journey, 540 million years ago, to the early Cambrian period. Using paleogeographic maps created by Christopher Scotese, we can follow the movement of the continents through time. 540 million years ago, Colorado was 30 degrees south of the equator and already part of the North American continent. It was near the western edge of a divergent margin. A long northward journey lay ahead. For the first half of the past 540 million years, Colorado was south of the equator. Colorado passed through the equator during the Pennsylvanian, about 300 million years ago. By 250 million years ago, a supercontinent had formed and began drifting northwest. By the late Cretaceous, 75 million years ago, Colorado had arrived at its current latitude. Now we see the continents as they are today. For a closer look at the geologic history of Colorado, let's go back 500 million years to the late Cambrian period. From about 500 to 300 million years ago, the late Cambrian to the early Pennsylvanian, Colorado was a low-lying area, periodically inundated by the ocean. Limestone and sandstones formed in shallow marine and coastal plain settings. These are now best exposed in western Colorado, along Interstate 70 in Glenwood Canyon. By the middle of the Pennsylvanian, two major mountain ranges had formed, the Ancestral Uncompahgre and the Ancestral Front Range. Rivers and streams carried sediment eroded from the mountains, creating braided river plains near the coast. This is what the Front Range may have looked like 312 million years ago. Dimetrodons, a type of proto-mammal, are standing on the banks of the stream, and some of the first conifers are growing on the peaks in the distance. The Fountain Formation, which makes up Boulder's iconic flatirons, was deposited in this environment. Farther south along the Front Range is another famous outcrop of the Fountain Formation, the Red Rocks Amphitheater. On the eastern flank of the Ancestral Uncompahgre Highlands, the rocks comprising the Maroon Bells were also deposited in braided streams and shallow coastal waters. 230 million years later, these rocks were tilted upwards to their current orientation by faulting during a mountain-building event called the Laramide Orogeny. From the late Pennsylvanian into the early Permian, the seas receded and the climate grew more arid. Winds began to rework the riverbed sands, and gradually the lush vegetation gave way to vast dune fields. Some of these wind-blown sands became the Weber Sandstone in northwestern Colorado. The Weber is the main reservoir at the largest oil field in the Rocky Mountain region, the Rangeley Field, with reserves of more than 1 billion barrels. Today, the Weber is exposed at Dinosaur National Monument, where the Green River exits the Uinta Uplift. By the end of the Permian, most of the mountains were eroded flat. Colorado was again a lowland area. The ocean pushed inland, and in some places, extensive tidal flats developed. These tidal flats were home to large fields of stromatolites. These slimy mats of cyanobacteria trapped and cemented layers of sediment, creating the wavy layered textures we find in their fossilized remains. From the Triassic through the Middle Jurassic, 250 to 170 million years ago, Colorado's climate alternated between dry and temperate. During the early Jurassic, large wind-blown sand dunes developed in western Colorado and Utah. Rifting of the eastern United States also began during the early Jurassic, about 180 million years ago. The Atlantic Ocean formed as the North American and African continents separated. By the late Jurassic, North America began to drift westward, and a convergent margin developed to the west. The subduction of the Farallon Plate, which sat beneath the Pacific Ocean, caused major changes in western North America. The early Sierra Nevada mountains formed. Sediment eroded from that area and flowed east in rivers across Colorado and the surrounding states. These sediments later became part of the Morrison Formation, famous for its many late Jurassic fossils. Colorado's state fossil is the Stegosaurus. The first specimen was discovered north of the town of Morrison, west of Denver, in 1877. Dinosaur National Monument on the Colorado-Utah border is dedicated to displaying and preserving the fossils of the Morrison Formation. The Quarry Wall, one of the main exhibits, has more than 1,500 bones from species such as Allosaurus, Apatosaurus, and Stegosaurus. The beginning of the Cretaceous, 145 million years ago, brought more changes to the region. Almost 40% of the rocks on the surface in Colorado are Cretaceous in age. Much of Colorado's petroleum and coal are from those rocks. Around 100 million years ago, the Cretaceous interior seaway began to enter Colorado. As the center of the continent flooded, shorelines crept across Colorado. The initial shoreline and related sediments became the Dakota Formation, which forms a prominent ridge along the Front Range. The Dakota is an important petroleum reservoir throughout the state. 100 million years ago, it was Colorado's east coast. It was a warm, subtropical environment. Dense temperate forests dominated the land. Dinosaurs and other animals inhabited the coastal margins. Footprints from iguanodon-like dinosaurs are exposed at Dinosaur Ridge, west of Denver. As the shorelines continued to move back and forth, large parts of Colorado lay underwater. The Niobrara chalk and related sediments were deposited in the shallow seaway 83 million years ago. These formations are well exposed in the southern part of the state, near Pueblo. They also form the unconventional reservoirs currently being developed in the northern Denver Basin. By 80 million years ago, the shorelines were present in western Colorado. Today, these deposits form several spectacular vistas. In the southwestern corner of the state, they make up the cliffs of Mesa Verde. Beginning in the 12th century, the ancient Pueblo peoples constructed dwellings in caves and hollows along the cliffs. Mesa Verde National Park is now the largest archaeological preserve in the United States. The Book Cliffs, north of Grand Junction, formed from shoreline and coastal plain sediments deposited between 72 and 75 million years ago. The upper cliff bands are made of sandstone. If we could look back in time to when the sand forming these rocks was deposited, we would see vast coastal plain swamps. Dense groves of cypress trees grew in the flooded margins of the swamps. The well-drained interior provided habitat for a variety of dinosaurs. Organic matter from these coastal plain swamps became the coal deposits of western Colorado. By 68 million years ago, the seaway had receded, and the first mountains associated with the Laramide Orogeny began to develop. During the next 8 million years, several major mountain ranges formed, some of which are still prominent today. From a paleo-satellite view, we can see the Front Range, the Park Range, the White River Uplift, the Uinta Mountains, the Uncompahgre Uplift, and the Needle Mountains. Faults adjacent to the newly formed mountain ranges tilted and contorted rock layers into the shapes that we see today. These strata were deformed by the Minton Park Fault, adjacent to the Uinta Mountains in northwestern Colorado. Hogbacks are the eroded remnants of these folded strata. The two longest hogbacks are the Grand Hogback along the western edge of the White River Uplift and the Dakota Hogback along the Front Range. As these high mountains were eroded, massive volumes of sediment were deposited in nearby lowlands. Rivers deposited up to 10,000 feet of sediment in some parts of northwestern Colorado. Some of these sediments form the multicolored strata in the bottom part of the Roan Plateau. Then, large lakes formed in northwestern Colorado. Lakebed sediments comprise the upper half of the Roan Plateau. These lake strata contain the largest oil shale reserves in the world, the Green River Oil Shale. The Mahogany Zone, near the top of the cliff, holds these deposits. Between 40 and 10 million years ago, igneous activity was a major force affecting Colorado's landscape. Although there are no longer any active volcanoes, the remnants of this period are scattered throughout the state. The 39-mile volcanic field west of Colorado Springs was one of several clusters of large stratovolcanoes. These volcanoes dominated the first phase of igneous activity from 40 to 28 million years ago. Fast-moving mud flows from volcanoes in the 39-mile field flowed into an ancient valley. There, they encased and preserved the bases of trees. These became the petrified tree stumps that Florissant is best known for today. The debris flows also dammed streams, creating lake environments that preserved fine details in insect and plant fossils. "28 million years ago, the period of stratovolcano activity evolved into a series of major caldera collapses in the San Juan Mountains in southwestern Colorado. At least 19 major calderas formed between 28 and 26 million years ago. The eruption associated with the La Garita caldera 28 million years ago was one of the largest volcanic events in Earth's history. Superheated ash and lava from the San Juan calderas extended for hundreds of miles around the state. Many of the stunning landscapes of the San Juan Mountains formed from the eroded remnants of these eruptions. About 25 million years ago, large basalt flows became the dominant form of igneous activity. Some of these flows form the tops of mesas in western Colorado, including the Flat Tops and Grand Mesa. This is the Crystal Mill, located near Redstone in the central western part of the state. It was built in 1893 to power one of the many mines that developed during the Colorado Gold Rush. The silver, gold, and other valuable minerals that brought European settlers to the area were formed as a result of the igneous activity between 40 and 10 million years ago. One other important product of this igneous activity is the Yule marble, Colorado's state rock. It was used in the exterior of the Lincoln Memorial and the Tomb of the Unknown Soldier at Arlington National Cemetery. The marble started out as limestone, deposited 350 million years ago. Over hundreds of millions of years, that limestone was buried by at least 10,000 feet of sediment. Then, 12 million years ago, magma intruded into the surrounding rock, baking and transforming the limestone into marble. Uplift and erosion during the last 12 million years exposed the marble at the surface, and quarrying began in 1886. The marble for the Lincoln Memorial was quarried from 1914 to 1916. The landscape in Colorado that we see today is largely the product of two processes that have operated during the last 18 million years: uplift and erosion. Today, Colorado is famous for its rugged mountains and diverse topography, but 18 million years ago, the region was relatively flat. Then, highlands began to develop because of uplift associated with the Rio Grande Rift. In some places, the highlands were raised more than 9,000 feet above their surroundings. Uplift created the high elevations, but erosion by water carved the rugged peaks and valleys that define the landscape today. The Continental Divide and major river drainages formed. Rivers to the east of the Continental Divide drain to the Gulf of Mexico. Those on the west side drain to the Pacific. Today, Denver is known as the Mile High City because its altitude is 1 mile above sea level. But the landscape around Denver has changed considerably during the past 15 million years due to extensive erosion. To see how much the landscape has changed, let's look at the town of Golden, just west of Denver. Golden sits in a valley that was carved by erosion. To the west are the foothills of the Front Range. To the east are two large mesas, North and South Table Mountain. This is a cross-section of the area. 15 million years ago, ground level was 2,000 feet higher than it is today, and the land was covered by dense forests. Through time, rivers carried away thousands of feet of sediment and deposited it in the Gulf of Mexico. Eventually, the prominent lava flows capping North and South Table Mountain were exposed as they are today. Glaciers also played an important role in carving the landscape of Colorado's high mountains. Several times during the last 1 million years, the high peaks were covered with glaciers. One area that bears the marks of extensive glaciation is the Gore Range, in the heart of Colorado's ski country. Here is the view of the Gore Range at 20,000 years ago, when it was covered with glaciers. It was glacial erosion like this that formed most of the rugged topography of the high mountains that we see today. The glaciers were at their peak 20,000 years ago. As Earth's climate grew warmer, the glaciers began to melt. By 13,000 years ago, they were completely gone from the area. Colorado has had quite a varied history throughout the last 540 million years. This history has left Colorado with the highest average elevation of any state in the country at 6,800 feet. There are 58 peaks above 14,000 feet, known as 14ers, and more than 600 13ers. A little-known fact, even among native Coloradoans, is that Gray's Peak is the highest point on the Continental Divide in North America. The state is rich in natural resources. Colorado's oil and gas industry employs more than 50,000 people and generates more than $29 billion a year. The state has more than 50,000 oil and gas wells in production. 12 of the nation's 100 largest natural gas fields are in Colorado. The Wattenberg Field is the fourth largest oil field in the U.S. The state is also home to 7 national parks and monuments. Among them are Mesa Verde National Park, where ancient cliff dwellings have been built in Upper Cretaceous shoreline sandstones. Black Canyon of the Gunnison National Park, where erosion by the Gunnison River has exposed Precambrian gneisses and granitic dikes during the last 2 million years. Great Sand Dunes National Park and Preserve, a large dune field that formed during the past 7,000 years from Rio Grande River sediments that were transported by wind and accumulated at the base of the Sangre de Cristo Mountains. Colorado National Monument, where Precambrian gneisses and Mesozoic strata are exposed in a series of picturesque canyons and mesas. Dinosaur National Monument, the first national monument dedicated to the preservation and display of fossils. Florissant Fossil Beds National Monument, dedicated to the flora and fauna preserved in mudflows and lakes created by late Eocene volcanic flows. And Rocky Mountain National Park, with its spectacular alpine scenery of Precambrian metamorphic rocks that were heavily glaciated during the past 1 million years. Beginning 150 years ago with the Hayden Survey, Colorado's geology has been studied by many geoscientists. This week, we honor and celebrate the contributions of the many scientists who helped us understand the marvelous history of the state and the Rocky Mountains. We thank you for watching this brief history of Colorado, and welcome to the convention.